Modernage MCQs Physics first year, unit number 6, Fluid Dynamics, part 3. The SI unit of coefficient of viscosity is option A, kilogram per meter per second, option B, kilogram meter per second, option C, kilogram per meter second, option D, kilogram per meter square per second. The key is kilogram per meter per second. Therefore, the correct option is A. Reason. In formula, Fd is equal to 6 pi eta Rb. The SI unit of Fd is Newton, R is meter, and V is meter per second. Therefore, the SI unit of eta is Newton per meter into meter per second, which is equal to Newton per square meter per second, which is equal to Newton per square meter second, which can be written as kilogram meter per square second into per meter square second equal to kilogram per meter per second. Hence, the SI unit of coefficient of viscosity is kilogram per meter per second. Water is flowing through a tube placed on a horizontal table of uniform area of cross-section A. The rate of volume flow of water R1, R2 and R3 at 3 points inside the tube is related as option A, R1 less than R2 less than R3, option B, R1 greater than R2 greater than R3, option C, R1 plus R2 is equal to R3, option D, R1 is equal to R2 is equal to R3. The key is R1 is equal to R2 is equal to R3. Therefore, the correct option is D. Reason, the rate of volume flow is R is equal to delta V over delta T, where delta V is the volume, delta T is the time, which is equal to AB. According to equation of continuity, AB is equal to constant. Therefore, rate of flow at every point of horizontal tube is R equal to constant. Hence, R1 is equal to R2 is equal to R3. Natural gas is passing through a pipe of uniform area of cross-section A. Which physical quantities should remain constant throughout the pipe? Option A, area, option B, speed, option C, pressure, option D, A, B and C. The key is D. A, B, C. Therefore, the correct option is D. Reason, the area of the pipe is uniform. The rate of volume flow is constant. Therefore, speed is constant and pressure is also constant. Hence, the option D is correct. 8 raindrops of same size and mass are formed in clouds. This start falling and after some time their terminal velocity is 11 centimeter per second. If they coalesce to form a big drop, then what will be its terminal velocity? Option A, 11 centimeter per second. Option B, 8.0 centimeter per second, option C 5.5 centimeter per second, option D 1.1 centimeter per second. The key is 5.5 centimeters per second. Therefore, the correct option is C. Reason, from the equation Vt is equal to mg divided by 6 pi eta r, we have Vt is inversely proportional to r. The terminal velocity of individual drop is Vt is proportional to 1 by r1 and big drop is V prime T proportional to 1 over r2. Therefore, T prime divided by Vt is equal to 1 by R2 divided by 1 by R1, which is equal to R1 divided by R2, or V prime T is equal to R1 divided by R2 into Vt, which is equation 1. The volume of big drop is equal to the sum of volumes of 8 drops. Therefore, V2 is equal to V1 or V by 3 pi R2 cube is equal to 8 into 4 by 3 pi R1 cube or R2 cube is equal to 8 times R1 cube or 2 into R1 whole cube. R R2 is equal to 2R1, which is equation 2. Putting equation 2 in 1, we get V prime T is equal to R1 divided by 2R1 into Vt, or V prime is equal to 0.5 Vt, which is equal to 0.5 into 11, because Vt is 11 centimeter per second. So this is equal to 5.5 centimeters per second. Hence, the terminal velocity is 5.5 centimeter per seconds. 8 raindrops of same size and density rho are falling with terminal velocity of 11 centimeter per second. If they coalesce to form a big drop, then what will be its terminal velocity? Option A, 11 centimeter per second, option B, 22 centimeter per second, option C, 44 centimeter per second, option D, 88 centimeters per second. The key is 44 centimeter per second. Therefore, the correct option is C. Reason. From the equation, terminal velocity is equal to 2 rho g divided by 6 pi eta into r square, or we can say that Vt is directly proportional to square of r. The terminal velocity of individual drop is Vt proportional to r1 square, and big drop is V prime t proportional to r2 square. Therefore, V T prime divided by Vt is equal to R2 square divided by R1 square, or V prime T is equal to R2 square divided by R1 square into Vt. The volume of big drop is equal to the sum of volumes of 8 drops. Therefore, V2 is equal to V1 or 4 by 3 pi R2 cube is equal to 8 into 4 by 3 pi R1 cube, or we can write as R2 cube is equal to 8 R1 cube, which is equal to 2 R1 whole cube, or R2 is equal to 2 R1. Putting equation 2 in equation 1, we get V prime t is equal to 2 R1 whole square divided by R1 square into Vt, or V prime t is equal to 4 into 11, which is equal to 44 centimeters per second. Hence, the terminal velocity is 44 centimeters per second. A 2-meter oil tank is full of water. A hole appears at its middle. The speed of efflux will be option A 3.75 meters per second, option B 4.90 meters per second, option D 4.42 meters per second, option D 5.11 meters per second. The key is 4.42 meters per second. Therefore, the correct option is C. Reason. The formula of speed of reflex is Ve is equal to square root 2gh. The depth of hole is h is equal to 2 by 2 is equal to 1 meter. Therefore, the speed of efflux of water is Ve is equal to square root 2 into 9.8 into 1, or Ve is equal to square root 19.6, which is equal to 4.42 meters per second. Hence, the speed of efflux is 4.42 meters per second. The systolic pressure of a healthy person is about 120 torr. In millimeter of mercury, it is option A 150, option B 130, option C 120, option D 110. The key is 120. Therefore, the correct option is C. Reason. The conversion relation is 1 tar is equal to 1 millimeter of mercury. Therefore, 120 tar is equal to 120 millimeter of mercury. Hence, the systolic pressure of a healthy person is 120 millimeter of mercury. The diastolic pressure of a normal person measured by a blood flow meter in tar is about option A 75 to 80, option B 75 to 85, option C 75 to 90, option D 60 to 80. The key is 75 to 80. Therefore, the correct option is A. Reason: the diastolic pressure of a normal person measured by a blood flow meter is about 75 to 80 torr. Hence, the diastolic pressure of a normal person measured by a blood flow meter in torr is about 75 to 80. Blood pressure of a normal person measured by a blood flow meter ranges from 80 millimeter of mercury to option A 90 millimeter of mercury, option B 100 millimeter of mercury, option C 110 millimeter of mercury, option D 120 millimeter of mercury. The key is 120 millimeter of mercury. Therefore, the correct option is D. Reason: for a normal person, the diastolic pressure is 80 millimeter of mercury and systolic pressure is 120 millimeter of mercury. Hence, the range of blood pressure of a normal person is from 80 millimeter of mercury to 120 millimeter of mercury. A 2.5-meter tall tank full of water has four identical small holes at heights 1.7 meter, 1.4 meter, 0.8 meter, and 0.4 meter. The speed of efflux is maximum from a hole. Option A 0.4 meter high, option B 0.8 meter high, option C 1.4 meter high, option D 1.7 meter high. The key is 0.4 meter high. Therefore, the correct option is A. Reason: the formula of speed of a flux is VE is equal to square root 2GH, where H is the depth of a hole. For minimum height, the depth H is maximum and speed of efflux is maximum. The minimum height is 0.4 meter. Therefore, its corresponding height is maximum and speed of efflux is maximum. Hence, speed of efflux for 0.4 meter high hole is a maximum.